All right, this video we're going to look at solving exponential and log equations in the next video, but that's the title of it, so solving exponential and log equations. Okay, so for an exponential equation, let's take a look here. Solve 2 to the x equals 8. Well, by guessing, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3, well that's 8. Okay, so we get x equal to 3. If you want to use logs, well, you could take log base 2 of both sides. Okay, so turn that into a log, and basically you get x equals log base 2 of 8. So that's a solution for it. Log base 2 of 8 equals log base 2 of 2 to the 3, because we can change 8 to 2 to the 3, and then that just becomes 3 because the logs and the base 2 cancel each other out. Okay. So another method using the change of base formula. Okay. So if you take the log of both sides, that's the process for finding the change of base formula, figuring it out. But you take the log of both sides, use the log that's on your calculator, log base 10. So log of that side, you bring the x down in front. Okay, so that exponent comes down using the power rule. And now we can divide both sides by log base 2. Or log of 2, not log base 2. And you solve for x. And x equals log 8 over log 2. That's basically the change of base formula. And if you do that on your calculator, you'll get 3. Exactly. Okay. Now, what about this one here? 6 to the x equals 231. Well, there's guessing again. 6 to the 3 equals 216. Okay. 6 to the 4 equals 1296. So it's got to be somewhere between 3 and 4, probably closer to 3, because 231 is much closer to 216. Okay. And if you guess and you keep checking it on your calculator, you're going to get about 3.015. Or 3.02 is a good approximation. Okay? Now, what about using the change of base formula? Well, if you take the log of both sides, okay, the x comes down in front, and then you end up with x equals log 231 over log 6. So this is just, we can just jump right to this using the change of base formula if you want. And do it on your calculator, and you get 3.0375. Okay. Now, what about this? 49 to the x minus 1 equals 7 root 7. Well, we can change the 7 root 7 to 7 to the 1, which is that, and 7 to the 1/2. We can change 49 to 7 squared. Now we have the same base for both sides, a 7. Okay. So we multiply that in, and because we have the same exponents on the same base, we can just match up the exponents. 2 to the x minus 1 equals 3/2. And now you're just solving for x. Okay, and x equals 7 over 4. Okay. And there's this equation here. So 4 to the x plus 3 minus 4 to the x equals 63. So what we need to do here is look at some exponent laws. 4 to the x plus 3 can be written as 4 to the x times 4 to the 3. Okay, so when you multiply the same base, you add the exponents. So it's just going backwards from that. Okay, and 4 to the x. Now I can factor out a 4 to the x on the left side. Okay, so 4 to the x is a common factor. 4 to the x times 4 to the 3 is this one. 4 to the x times minus 1 is that. Okay, then I can evaluate that. 64 minus 1, which is 63. Okay, and then 63 divided by 63 is just 1. And I get 4 to the x equals 1. And the exponent then has to be 0, because anything to the 0 equals 1. So we got 4 to the 0 equals 1, so x equals 0. next, we look at this one here. 3 to the x plus 2 minus 3 to the x plus 3 equals negative 24. Same idea. Okay, change that to multiplications. Factor out the 3 to the x. Okay. And we've got negative 18 in here. Divide both sides by negative 18. And you get 3 to the x equals 4/3. Then you can take the log of both sides. Okay. So the x comes down in front. And you get log 4/3 over log 3. This is approximately 0.26. And that's the way of solving that one. Okay. What about this one? 3 to the 2x minus 5 times 3 to the x. Okay. So if we want to take out a 3 to the x here, we got to turn this into multiplying. Okay, power of a power. So 3 to the 2x is 3 to the x to the 2. Bring the 6 over. So we've used this rule here for this part. And we have a quadratic. That quadratic looks like this, where a is 3 to the x. Okay, so a equals 3 to the x. We got a squared minus 5a plus 6 equals 0. And we can factor this. And we get a equals 2 and a equals 3. So we just replace the a with 3 to the x. And we've got this. So we get 3 to the x equals 2 and 3 to the x equals 3. For this one, it's going to be log 2 over log 3. 3 to something equals 3. X has got to be 1. Okay, so this one, log 2 over log 3, x equals 1, which is approximately 0.63. Okay, or it's log base 3 of 2, if you don't want to use your calculator. Okay, so here are the solutions to that one. Okay, and that's log equations, or exponential equations.